Hello, we're the Samueli Fist Fighters, and this is our design presentation for the 2023 hack event that we attended. And I was responsible for the CAD design. For our gauntlet, we wanted to aim for three things: simplicity, functionality, and aesthetics. And so for simplicity, we designed to choose not to use a 3D printer, but rather use a laser cutter because we wanted to go through as much as iteration as possible, where a 3D printer won't allow us to do that because of its time that it takes to process and print. And for the functionality, obviously, we wanted to make everything work, all the sensors, use all the components, the OLED screen, while also having it, again, keeping it simple. And then for the aesthetics, we wanted to keep the circuits unexposed from the outside. So we wanted to have it clean as possible. So for the first iteration, we had just one simple part. And this is an example of one of the plates that is in the front. And as you can see at the assembly, it's just composed of 6 plates and they are glued together. And this accomplished one thing, and we realized that this was the perfect dimensions for our gauntlet design. So the overall dimensions were okay. However, we had to glue the parts instead of being able to assemble it without having to use anything. And so we realized that there was not enough contact points. And also, as a minor issue, the handle, the part that we hold our gauntlet, was too high. So the top of our hand interfered with the top of the plate. And so in order to solve those issues, we came up with the second iteration. And so the image on the left here is our first iteration and one of the plates. And on the right is the second iteration. And as you can see, we chose to go for a puzzle-like part so that we can increase and have more contact points between the parts. And also we solved the handle issue by lowering the holes that we have for the handles to a little bit lower place. But in this iteration, we still lacked the holes that we needed for the sensors. And the holes, they need really precise positioning as well as the size of the holes, because again, we didn't want to expose any part of the wire. So we wanted only the sensors to be sticking out from the outside while also keeping the wires on the inside. Also, it lacked swag. So our final iteration, we had to go through multiple steps and again, design processes in order to have the perfect size. And this include the OLED screen, the sensors, the buttons, LEDs, everything included had to go through multiple iterations in order to make sure that these parts would be able to fit perfectly. And so this was our final assembly. On the left, you can see it in SolidWorks. It is perfectly fit. It is the puzzle-like parts hold the parts together without needing much of glue. And then on the right is the actual final assembly. This is for the side plates, and we added a logo, a little bit of logo design, our team name, as well as a gauntlet sign holding the fist part. So that's it for the CAD design. I'm going to pass it on to Kelvin for the circuits part.
In our circuits design, we focused on functionality and minimalism. So only the electrical components and parts necessary for the rescue was considered. We avoided potential bloatware like the servos, which might actually hinder the task instead. We also focused on stability. We had 2 circuits, both that worked with the current iteration. One was kept as a safety or backup, while the other we could use to work on the next iteration. In our first iteration, we will use the bare minimum components, with the OLED screen and the gas detector. In the second iteration, to notify the e-hero when there was danger, we had the red LED light up accordingly, otherwise the green LED would light up. The buzzer would also sound when it was dangerous. In the third iteration, as we realized the collapsed building might be dark, we needed a light source. So we used the ring LED and the button to imitate our flashlight. In the next iteration, to account for potential fires, we added the temperature and humidity sensor. We encountered a problem in this step, as both the OLED and the temperature sensor used the same SDA and SCL pins. We had to look up documentation and adopted the one-wire communication protocol, which solved the issue. In our last iteration, we added ultrasonic sensor, as we realized we needed it to determine which room the engineer was in. Our engineering mindset was one that focused on innovation and reducing uncertainty. We didn't take any ambitious steps, instead chose smarter, safer steps that guaranteed everything would continue working. The greatest challenge was implementing the ultrasonic sensor. We even tried replacing the sensor and checking the code with the size to make sure it was correct. Despite all that, the sensor continued to be 0. It was only when we swapped it out for the third sensor that started working. We neglected the possibility of multiple hardware failure. Next time we would also more thoroughly read documentation, as not realizing this ultrasonic sensors required 5 volts instead of 3.3 volts like the rest of the component took up quite a few hours. In our code, we first assign each component to its pin. In the setup portion, we then read the sorting code for each component. We first read the gas level, then the ultrasonic sensor data, then the temperature and humidity. Along the way, we would print the data onto our OLEDs. To determine the current state of the room, we defined several state variables that would toggle true or false depending on the thresholds. For a flashlight to work, we had a button state, and if the flashlight was off, it would turn on, and vice versa. To determine whether the red LED, green LED, and buzzer would work, depending on the state variables we defined above.
Hello, I'm Ryan, and I'll be covering the communications and website portion of our hack. So, getting right into it, for our Arduino code, we used the given example code to kind of like help start off. So, we used we obviously need to declare or include the hack publish.h. We need to declare the publisher and what name it was, and then we need to connect our ESP32 to the Wi-Fi, and we did that here, and we saved the password and SSID for the makerspace up here, and then we made sure to begin the publisher right here, and then we went through and collected all our data for the sensors and whatnot. And once all of the data was collected, we would send it to the website. And then obviously here we have the variables that contain that are the same as the one on our HTML file, so that they can properly send the correct data from the ESP32 to the website. So here we see humidity is named the exact same as it would be right here on the HTML file. Here's what our website looks like. So we did a bit of a stylization. We created a couple of classes to kind of give each of these like images like kind of more of like a boxy feel, like so they all feel like self-contained in each other. Like the gas level has its own box, so does the temperature and whatnot. And we also wanted to give more personalization to it, so we decided to add some like anime characters from One Piece and Dragon Ball to kind of make them feel more unique. And so, we can see here that these are the classes we used to give the images and the text below them. They're like boxish card shapes. And so we also had one image that would change, this one right here. So when the area is safe, it would display this image of Goku. And then if let's say the humidity went below 45%, or the temperature went above 32%, or the gas level went above a certain threshold, then over here we can see that we have a function to change our images. And if one of those values exceeded or fell below what was considered safe, then the image would change. And so that would update every 10 milliseconds, I believe. And then right underneath that, we have the technical explanation of our hack. I believe that is about it. So yeah.